run that loop one time for every line of this file. And so the lines we're going to get back are bytes, and so we have to say decode. It doesn't do that for us automatically. We are going to have to decode them, and that's because we might need to decode them with a particular character set here. And then we're going to do our strip, and we're going to just print this out. So that's like open a file, read through it, and print it. This is open a URL, read through, and print it. And that's as simple as it is. And so that's what happens. This is romeo.txt, and it prints out. Now the thing to notice is that there are no headers here. The headers have been sort of consumed in the URL open. Again, there is a way to say, hey, give me my headers, but for now, this is just going to eat the headers and keep them, and then you get to read all the data, and the loop runs, and this loop runs 4 times, and out come the 4 lines. You can go ahead and run this one. It's super easy. I mean, literally super easy. And if you can do anything you want. I mean, treat it like a file. You just have to remember to do the decode bit when you treat it like a file. And so that code import it. We're going to open it. We're going to make a dictionary. We're going to loop through. We're going to split it. We have to add the decode just to make sure, because that line is bytes, not string. And then we're going to go, our words. We're going to go through the line, and then each line we're going to bounce through the words. The inner for loop is bouncing through the words, and then we're going to go to the next line. And then we make ourselves a dictionary, and we print that dictionary out. Now this in effect, other than importing this, opening it differently, and doing the decode, this is exactly how we would process a file. And so by using urllib, you really sort of reduce the complexity of retrieving and reading network resources to the same complexity of reading and dealing with a file locally on your hard drive, which is kind of pretty. So one of the things then we can do is read web pages. That was a text file, but you can get HTML. And so here's how you read a web page. And it's the same kind of code. We open a URL. This one happens to have HTML in it, and we read through it, and out comes the HTML. Remember that the headers are there, but they've been eaten by URL open for us. And now we could write a browser that would parse these less thans and greater thans and make links, etc., etc., etc. So if you can come up with ways to find these links, you could actually write a bit of code that would then have a loop that would go up and open a new one. Pull out the links, open a new one. Pull out the links, open a new one. And so you could make a thing that would retrieve you could write a program that would retrieve a page, find the links in the page, and then retrieve those links. And we'll actually do that before the end of the class. And so Python is a very popular language at Google, and I wonder if I think it's a pretty safe bet that the first crawler that they wrote to crawl the web, to build the index, was Python, because literally that's all it takes to read web pages and pull those web pages into your web crawler database. So I don't know, are those the first 4 lines ever written to Google? Who knows? So the next thing that we'll talk about is how you handle that HTML. HTML is kind of yucky and nasty, and so it's not as simple as regular expressions. Regular expressions might help, string parsing and split might help, but it's just too crazy. So we'll talk a little bit about how to use a library to make HTML parsing a lot easier. We are going to be talking about some code. If you want to download all the code, it's right here. It's all single big zip file. And all this sample code, the one I'm going to talk about is urlwords.py. It is not very exciting. It's short. That's what's kind of nice about Python code. And it's really, if we go and take a look at the code we played with just previously, which is socket, the idea here is urllib is something that Python has produced for us to make socket communications and HTTP communications a lot better. So socket, this is making socket calls underneath it, but there's a library that makes this quite simple. And so we have to do some imports. So instead of importing socket, we'll import these URLs. We are going to create a handle, URL request URL open, and just pass in a string. So we're not encoding this, we're not sending get command. All the stuff we did in the previous sockets example is gone. And then we can just put this as a for loop. And so we're not using this lower level read and write code, we're just using a for loop. And so that literally is going to read the text line by line. and the line does come back as an array of bytes, so we have to do a decode, but then we got a string, and then we can do a strip on it. So this is like a super simple. So there we go. Now the interesting thing is you also don't see the headers. We just read the contents. Now it turns out in urllib, and we'll see this in later more complex application, you can get the headers if you want. You can get various other things. So that's urllib, a simple urllib tool. Now we can also use this in urlwords to show you something quite interesting, and that is, if you look at this from right here, other than the decode, this is exactly the code we wrote to compute the words, right? So other than this line.decode, this is just a open something up. In this case, we're going to open a URL. We're going to create a dictionary. We're going to loop through each of the lines in that thing. We're going to decode them and then split them. So once you do line.decode, this is now a legitimate internal Python string. We split it, we run through the words, and run the counts. And so this is exactly like code that we did before to run counts. And so Python 3 URL words. And so that gives us a dictionary, which is the word frequency. And we could do all kinds of crazy stuff in here, you know, with sorting and all the kinds of things. The important thing is once you've done this and this, the code, other than the need to decode these lines when you first get them, it really works just like makes a urllib makes URLs function inside Python very much like files. So these are short and to the point and very simple, and I hope that they were useful to you. So now we're going to talk about what you would do with a web page once you've retrieved it in a Python program. Call this web scraping. And so web scraping or web spidering is the act of retrieving a web page, extracting the links from those web pages, making a queue of unretrieved links, and then moving on. And eventually the idea is if you had enough time, energy, bandwidth, and storage, you could find your way to most of the web pages on the internet that are point to or are pointed to by other web pages. And so you might have all kinds of reasons to scrape data. You might have a blog that you posted. You might have, who knows, maybe you put some data in a system. Maybe the system's being shut down because it's being retired. You can do all kinds of things. You could write a little thing. I was talking to somebody who wrote a thing to retrieve something and check, and then send a text when something changed. All kinds of stuff. Or you might make yourself a search engine. But be careful. Not all websites are happy about you using a robot to retrieve their content. Some of the websites, as we'll see, demand that you log in and they track what you do, and if they think you're doing something bad, they will shut your account off. Other websites will track what you're doing without you logging in, but then shut your address off. And so you have to be careful. You should read up. You should figure out what sites allow you to scrape them. Now I have some sites that I've set up that you can play with to make it so that it's legit. So parsing HTML is difficult. Some of the simple examples, you could probably write a regular expression or, certainly some splitting and some whatever. And what you would find is you would write that code and you'd retrieve your first 5 web pages and it would seem to work, and then it would encounter some really weird but legitimate HTML. Or maybe even sort of slightly broken HTML. So the web is full of broken HTML, and your browsers just look at it and go like, oh wow, more broken HTML. But they don't put up error messages, and so people just leave broken pages up. But your Python program is going to see those broken pages. So what you would do is you'd be like, oh, here's a new weird way to do an anchor tag. I'll change my code. Oh, and then run for another 100 pages and like, oh no, here's a new weird way to do an anchor tag. And the problem is that you're going to find a lot of different ways to mess up an anchor tag. And someone has already done that. There's a software called Beautiful Soup, and we have installation instructions on how to use it. And really what it is it's somebody just spent months figuring out all the nasty things that could happen and compensated for it and gave you a nice wrapped interface that just says, look, you give me the HTML and I'll give you back the tags, okay? And so it's called Beautiful Soup. And so you have to install this. There's a couple of ways that you can install this. If you're good at extending your Python, you can just, extend and install beautiful soup for all Python programs. If you can't change your